I'm late, I'm late, I'm late for a very important date. I'm late, I'm late, I'm late to start streaming again. I'm late, I'm late. Okay, so let me just boot up a few things here. We'll get some music going. Today is bit set day. We're gonna do a lot of bit set stuff, but we'll talk about it. We'll talk about it today. It's gonna be funny. It's gonna be dandy. Oh my goodness. Let me turn on some music here. We haven't listened to Star Guardian in a while, huh? Star Guardian sessions. I like the Star Guardian session one. It's pretty dope. There we go. Now we're jim jamming. Okay, let me just copy this. Paste. Delete. Copy, delete, at everyone. Okay, so, wow, that music was so loud. I am so sorry. I just saw that. Okay, little loud. My B. Okay, that was my B. Well, we lowered the volume a lot now. So, we're gonna do bit sets. Let's just jump right into it, baby. We're still doing ECS architecture, but we're gonna do, oop, that was the wrong one. But we're still gonna do, we're gonna do bit sets. I like bit sets. We're gonna do some bit set math here. So let's move this over here. Remove this situation. Oh my goodness. No, this one. There we go. A little more, actually a lot more. Let's go like here. I don't like how small that is. I guess the text is still pretty readable. We'll just have to make Gary a little bit more tucked in. There we go. A little bit more of a jam. Something like here. I think that works. There we go. All right. So we're gonna make stuff. All right. Let's get rid of a lot of this. So I was thinking a lot today. Code toil. About how we're going to be doing this and how we're going to like store components and all that in our entities. I think the conclusion I've come to, we'll ignore the tuple components for a second. I think what we're going to do is have an entity class for every entity where we're going to have, as part of its constructor, we'll go over that, but what we're going to have is a bit set. And for now, we'll call it just bit set, where it's going to, oh, sorry, the value of it. We'll say like, how many components are we gonna have? Potentially, every component in the game. 100? We'll say 100 for now. Some arbitrary number, bit set. So this bit set, it defaults, if you guys don't know anything about bit sets, do I need to go over this? Hold on, I'll go over this. Paint. What is a bit set? Okay, so a bit set is just some series of numbers of like 1, 1, 0, 0, 0, 1, 0, 1, and all that, right? So a bit set says I can manipulate and use every single one of these. It's like a vector. Think of it as like an array of booleans, not a vector. It's not variable length. You establish it once and it's there forever. But we have some boolean value in every spot. And I think we're going to use this as a way to tell what entities have what components. And if we ever need to reference this, there's actually something called a standard bit set reference. And this standard bit set reference will be how we find, has no storage class or type specifier. There's a reference for bit sets you can use, and that's how we're gonna find the individual values. Otherwise, we are free to just be like, okay, flip this value, or flip all the values, or move stuff to the right or left. We're not gonna do any of this, but bit sets are pretty cool, and they're really tiny. So these 100 length bit set is just 100 bits wide, which divided by 4 is 25 bytes. So we can tell every entity in the game at a glance if it has a component or not by just flipping on a bunch of flags. Now, this is where the tuple comes in. The problem is the way I'm going to program the game, I want to be able to, on a whim. Here's the thing, right? I don't want a situation where I have an entity and it take up more memory than it needs to. What I'm thinking is, if I want to program it in a way where if I set any of this bit set, any bit in this set as on, so instead of, you know, whatever it is, 0, I would set like, oh, this component, I want the player to be damageable 1, right? Set that bit to 1. I want to do it in a way where maybe we just, because this is an engine I'm going to do by hand, right? So maybe every struct in this, all of our components, every struct that contains a component, I'm thinking what we do is, what we could do is attach some sort of value to it in order. Alternatively, I guess the easier way would be just to have a vector containing every individual struct, and that vector we could then use to change that value in the bit set. Basically, I don't want to like manually go in and be like, okay, count 1, 2, 3 structs in. Okay, the third bit I'm gonna flip. I don't want that, right? The goal is we have a vector of all of our components. We have a bit set that every entity has, and depending on what we want to happen, it will change certain bits, right? So what I could do is I want to be like, okay, I want to make a new bullet, but rather than like copy pasting a bunch to recreate what a bullet is as an entity in terms of how I want it to work like at a base mechanically, what I think I might do is be like, oh, if it has a tag, well, there's the tag bullet, because it's important to tag things for like, you have like a bomb or something in the game and it destroys all bullets on screen. You want to tag things that are bullets. I'm thinking bullet in like the don't recreate work sense, where it's like operationally, it's, you have a fireball and a frostbolt. They're both bullets, so they're both going to behave very similarly. What's like an easy way to establish this? I guess what I could do is have a certain, maybe we even have like, oh, I was about to say a struct of structs, some sort of data where it says, hey, if I want to make something have bullet values as like a default, maybe certain bits are flipped up automatically. But then again, that would be like mental space of like what's enabled. Alternatively, I could just have every entity be its own thing that I manually give values to via an XML document. But then you have the problem of like UI. Well, hold on, what is UI besides is clickable, has a graphic, an XY value? I guess that's not that different. And I guess we'll give this Boolean is alive equals true. Oh, wait, that's wrong. Hold on. Auto is alive equals Boolean true. Should I set that to true by default? Auto is not allowed here. Why? Is it because it's a class and the value isn't given yet? Is it like, what if I give it like a const? Nah, it still doesn't work, huh? Interesting. I guess I want to set things to is alive equals false by default, huh? Now this, I can't do this either, right? I can't go like auto mid equals int. I can't do that. Yeah, it won't let me. Interesting. My always auto doesn't work in my entity. Okay. So I don't even know if we're gonna need a tuple is the thing. I don't think we are. I think tuples are great, but the problem is I need runtime reference of like what components are there. So I think this is the easiest way to do it. Now, the issue I have now is if we're using this, the hell? That's my phone. Now, how are we gonna, hold on, let me think. So we're gonna make every component. It's fine. Okay, so now we have a way. I guess we can call this M components now. M components. When you initialize a bit set, it always defaults to 0. So that's good. That's what we want. And we flip it to true whenever a component's added. Now the problem is now that we give it, you know, an XY value position point, the bit set for position, whatever, the position 0 in this bit set is now flipped to 1, right? Cool, wonderful, fantastic, right? But we have a couple of problems. If later on we want to iterate through this bit set, right? How do we do that easily? What I'm thinking is, like, if we have a system that says, okay, for all entities that have, you know, HP, right? For all entities that have HP, check if is damageable, like a really simple thing, right? Or maybe the opposite, maybe check if it's damageable, and if it is, check if it has HP. What I'm worried about is how would I actually iterate through this bit set? I can make an iterator. It's not that hard, right? What is an iterator but a glorified pointer? But my issue is how do I know if an individual component is available in that bit set without actually memorizing where in the bit set it is? That's why I think maybe we assign an integer to every single one that's like const int I forget what this is called. Midnight Royal Afton, hello, how's it going? Hi. So maybe we give every struct, every ECS component, maybe we give every component some int value of, like, I don't know what to call this. It would be like R value. We call it like that. R val. And we set this to 0. So no matter where it is, it's always referenced as 0. Now, I guess we could be cute and store a bunch of standard strings and then just make a bit set that takes in all of the standard strings, but that's confusing. So if we set this R value to 0 and this R value to 1 and this R value to 2, and just every time we add a component, we just look at the previous thing. No, I don't like that. It's too much work. It's an unnecessary amount of work for programming, right? Bonjour, Gary. JRR. Hello. How's it going? Welcome to the not wearing a white t-shirt stream. We're in a polo today. Chat, hold on. Did somebody text me? Am I risen? I am risen. Hold on. That's awesome. You're going to school. Yeah, I like to cook too. Oh, a still life. Sorry, hold on, I'm rizzing. Okay, there we go. I'm done rizzing. The Riz has been done. I'm fantastic. 4th of July weekend. Yeah, I got tomorrow off, baby. It's gonna be awesome. So what I'm gonna do tomorrow is just do a bunch of essays for school to get more caught up for the week, and then relax, stream, maybe go out for coffee. I don't know. I got options. I got the whole day off, baby. Yeah, I know. I got a pseudo long weekend. I'm working this Friday, but whatever. So what's a better way to do this than giving everything a const value? The thing is I guess I could have an enumerator. That wouldn't be that bad. Actually, that worked out pretty well. In fact, I don't even need an well, no, I don't want an enumerated class. I just want a raw enum. So it'd be like export enumerator, component list, and this is gonna contain, I guess we can just call this all components. So what we would do is we would have position equals 0. Oops. And then we would have velocity equals 1. Do we do it that way? Because if that's the case, then what we can do is we can have just a single like for loop iterate through this entire bit set and just give it those values. That would be one way to do it. Actually, no, you wouldn't even do that. No, that's dumb. What you would do is you would reference this enumerator of every component, and you would say, okay, damage type water, you have the value of 12. So I know the 12th bit in this bit set stands for you. So that if that's flicked on, you have that component, and now I care. One of the few times I actually want a raw enumerator. We don't want an enumerator class because you can't decide. Ooh, C++ question. Oh wait, I never had this problem before. That's cool. Can you assign integer values to enumerated class components or values? Like I know with a raw enum, they're already like integers, right? Normally this is bad, but in our case, it's like uniquely appropriate. If you have an enumerator class, can I still have 0, 1 and all that so I can use these names elsewhere? So we'll just call this bounding rect equals 2. This is so weird, but I think this is appropriate. Actually, I like this a lot because it means, yeah, it's a little bit verbose now, but like, dude, having like some sort of system like this means that it's going to be super easy to automate all this. So later on, I can be like, oh, okay, so check if health, right? Check if health component equals true. I should call these C, huh? I should call these component. Whatever, we'll go with this for now. The idea is like, okay, when I have my systems and I iterate through everything, we can check if entity has in its bit set spot, you know, color hurt box. I don't need to know by memory what value the color hurt box is, but it is in it's bit 5 because it's 0, 1, 2, 3, 4. It's the 5th bit of this huge bit set. Okay, it's on. Okay, you have that component. And then I'm just going to operate as if you do. It means that we don't need like a tuple or anything of like all the possible components, and then we turn them on via giving it a shared pointer later. We still have to give it a shared pointer, but it's going to be, this is more like what I want out of this because we're going to be turning off and on values a lot. So even if we already have a shared pointer for the entity, like if you're a player and you get frozen, you lose the ability to move. You turn that bit, hold on, where is it? Is controllable. You turn that bit off on the bit set, but you still have the associated shared pointer or unique pointer with it that still exists in the entity object. It still takes up memory, but because the bit in the bit set is off, it doesn't do anything. Systems assume, oh, okay, there's no value to worry about here. I'm not going to let you move the player because there is no component that's active for it. Bye, I gotta go. I'm sadly busy. No problem. My character slaughtered around 40 enemies in this game session. Ooh, it's gonna be fun. I think this is the correct way to do things. It's gonna be super specific, but if damage type fire, if damage type water. The good news is I never have to pay attention to what order these are in or anything, as long as they exist. I guess I could group these in its own thing, like, well, I was about to say, the way the college course taught it was you combined position and velocity under a transform component. I don't like that. I don't like that at all. I don't think that's, when I think of a component, I think of like, oh, a velocity, this is just an XY value, like X speed, Y speed, because it's a 2D game. position, X value, Y value. It's a point in space. Now, the college course taught, okay, if you're gonna have a component, you're gonna call it transform component, and the transform component contains a position and a velocity. But I don't like that, because these are the same components we're going to use for our AI. Are we really going to have our AI, our UI? So if our components have a U, we're going to use for our UI because it's an entity. Are we really going to have a transform component on a UI? Well, no. I just want my position component and a velocity component, and then let some system transform them as needed if we ever do. And if worse comes to worse, we give like velocity some values to make it easy to add with points. I don't know. We'll figure it out. So is damageable is bit number 10. Is shooting. Oops. Is 11. Is moving. Do I call these is moving, is shooting, is damageable, or do I go moving, shooting, damageable? I think I like that more. Yeah, I think I like this more, where it's not is the thing, it just is it. You know, you're not is controllable, you are controllable, you know? Feels like it's less verbose. So this is going to be the basics of our bit set. Well, the basic of our bit. Oh, and here's the coolest part. We just have to do this plus 1 as the size of the entity's bit set. So 13. We do Yes, we do 13 bit set size because there's 13 elements and it starts at 0. So it would go to element number 12, which is here. So there we go. Whatever this number is, we just go n plus 1, and that's going to be the size of our bit set. We can't put it in a variable. It's not, it's what is it? A const expression. The value needs to be known at, I can't go like X. Yeah, it's going to tell me no. It needs to be known. Well, hold on. Int X equals 5. Yeah, non-static member reference. But if I did, I bet if I did const expression. Well, maybe that still doesn't work. Damn. Non-static member reference must be relative to a specific object. I think you can do standard string though, right? Oh, no, you can't. Oh, there you go. Oh, in any case. Hey, Gary, it's good to see. Looks neat. What? Hey, Gary, it looks neat to see both you and your Goo Boy avatar. Oh, hell yeah. I still can't stand the font for your IDE. Oh, Seru. Oh, you're gonna make me want to change it. Hold on. Options. Font. Not Victor Mono. Oh no. That's for chumps. We need... Where is it? Where is it? Hold on. Hold on. Where is it? Cedarville. Oh yeah. We're gonna program like this for a little bit. I think it'd be fun. All right, so this is, by the way, my preferred font, but everybody always freaks out about it because they don't like cursive. But I think it makes sense. So when we initialize our entity, are we gonna need anything else but an ID? Yes. I think, so there's two ways we can do this. We can either have a standard string where the standard string is the tag type, which we're gonna make equal default, I guess. Default being no values at all. So when we initialize it, we're gonna need an int ID, and we're gonna need a standard string by reference value. Fuck. What's the good name? Tag. We'll call it that. And then we'll have oh, M tag is a better name for it, I guess. M underscore tag. M underscore is alive. And then something like, when we initialize it, it's going to be M tag parentheses tag no body. Okay, there we go. Now we initialized it. All right, now we turned the font off because none of you like it, and I know you don't. All right, Victor Mono, semi-bold, go. There you go, chat, readable again. Now this doesn't look so bad, does it? Now you're like, oh man, this is way more readable. Gary, use a monospaced font. They're literally for programming, so shit lines up. It's lining up. This is monospaced, isn't it? This looks pretty monospaced, chat. This is very monospacey. Oh my god, please, it hurts. So what is your Goo Boy eye prescription? Oh, it does. I don't have a prescription on my Gary the Goo Boy model. It's a zero. It's like one of those Amazon see-through glasses, but a Korean girl gave them to me once, so now I'm obligated to wear them. All right, so now we initialize an ID and a tag. The ID is not something, we don't actually create entities here, by the way. No, we're gonna have an entity manager. Entity nanny? I don't know. It's my game. I can program however I want. Then again, this is probably going on GitHub, huh? This is going on GitHub, and people on GitHub are mean, so maybe we won't use funny names. We'll go entity manager, and this manager will handle like the tag and the ID and all that. I think this is all I want an entity to be. Oh, we need to add and subtract. True. Okay, so let's make. We're using RAII, so any given entity is gonna already be a unique or shared pointer. Chat, I have a question about memory. Maybe you don't have to know C++ to answer this, but just memory in general, I guess. If you have an entity class object and it's wrapped in a shared or unique pointer, so RAII, when nobody owns it and it is to be cold, it frees its own memory, right? That's how RAII works in C++. If you have an RAII'd object like entity, and then you reserve more memory under it for like a standard string or something, and you don't wrap that in a unique or shared pointer system or something, and the entity gets deleted, does the memory associated with that entity also delete itself? Is that also not out of scope, but does C++ programming know by default that if I have like this integer value, right? That integer value frees itself if the entity object frees its own self, right? In other words, do I need to make all of these components shared or unique pointers if the entity itself is a unique or shared pointer? I actually don't know that. I actually don't know. We'll see. We'll see, chat. We'll see. Okay, so then we have all of our components. Now, what do we do with it? What we're gonna do is we're gonna have an add, well, it's gonna be auto, add component. Do we want this under the entity manager or the entity? It doesn't matter. If we have an entity manager, it would end up looking something like entity manager. How about this? E manager. And this E manager, what we would do is we would call add component, parentheses, the entity of choice, and then whatever component we want to add, which in this case would be referenced up here, add position, right? Now, this value, by the way, is just going to be an integer when we actually call this function. It's just we're using this enumerated class, right? So it'd be under position. Cool, right? Now, that would add it to here. Now, I don't think I need to add this under the E manager, right? Alternatively, I could just call it via, entity.add component, and we would just add the position value. Does that look cleaner? It kind of does. But then what's the point of an entity manager? Oh, no, we do want an entity manager. Entity managers would have the vector that contains all entities. Yeah, okay, that makes more sense. Okay, so that's how we're gonna call it. So we're gonna need a int component. And with that int component, we're gonna return we're gonna return void. Okay, so what are we gonna do here? So we have our component, which is some integer value. This integer value will be represented via this somewhere else in the program. So if I send over velocity, it's going to equal 1, damage value equals 6, and all that, right? But we don't know which one it is. Just going to be a component. Now, what we have to do is we have to get that bit set, which is going to be m components bracket component dot flip. I don't know the syntax for this, and I'm probably doing this wrong. So we have our m components containing a component. Then we need to flip it, but I don't remember the exact terminology for a bit set to just flip a value. Is it just flip? CPP reference bit set. All right, CPP reference, my hero, the greatest website to ever exist. All right. Size, count, any, all, test, operator. Ooh, I guess I should error report first. What happens if you add a component that's already there? I guess we just accesses specific bit. Sets bits to true or given value. Flip, that is what it is. Okay. So flip would look like bit set for flops. C out flops. Flops dot flip parentheses 0. Oh. So it's actually m components dot flip parentheses component. That's what it should be. Okay, that's kind of based. Well, he does look smarter. Oh, I see, I see. Okay. And that's it, right? Assuming, well, obviously there's no error reporting here, right? You don't want a situation. The reason why you need error reporting is because this is just the add component function. So what happens if the component is already added? What happens if you already have like a projectile component or like a position component? You didn't even realize it. Well, this would flip it to false, which is obviously a bug. So we need error reporting, but I think that's really all we want this function to do, right? Just flip that specific component in that bit set, and that's it. Then now it's true. Oh, but we also have to account for the actual data. Shit. How would we do this? We would have to make shared that specific component, which means we need a way. If whatever you give me here, it gets turned into an integer. So we need a way to undo this. Where if this has health of 5, grab this struct and give it to there. So it'd be something like health. Oh. Really shouldn't give these the same name, huh? We'll call this C then. There we go. It probably likes that a lot more. So C health is now an object. Okay, sweet. This compiles, right? Hold on. This does compile. Uh-oh. Warning, float to int. Requires narrowing conversion. This is a local variable and this is a float value. So we're converting this to, oh, 16, 10, 1.5 divided by 20. Oof. Okay, we'll try that. What's the error? Unexpected end of file found. Okay. Initializing float to int, possible loss of data, double to int, requires a narrowing of conversion. I guess I could just make everything a double. So this is dot zero, dot zero. This takes integers, so it's gonna round off anyway, but whatever. I just don't want to I just don't want the resolution to be kind of screwed up with this 1.5 divided by 20. I guess I could just increase it all and just make it all integers. Ugh, fine. We'll make everything an integer. Jeez. So this is 3 divided by 40. There you go. Conversion from double to int requires narrowing conversion. Oh. There we go. No more warnings. There we go. Unexpected end of file found. End of file is usually a messed up squirrely brace. Curly brace. Curly brace. Is it this? Unexpected end of file found. Is it the enumerator values here? That needs curly braced, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values starting at 0. 1. Just select each ending brace and see if Visual Studio matches it to the opening one. It should. I mean, there's nothing really to... It might be this. It's really hard to say. It says... I wish it would tell me where. Components.ixx parentheses 72 comma 1. Is it this? Does it need another one or something? What the fuck? No, this doesn't work. Error. No matching token found. Okay. So why is this giving the error? Oh, I need a semicolon after the entity class. Thank you, Seiru. You know your stuff. Thank you. All right, now we good. Okay. Next, trailing identifier illegal in base member initialization list because I forgot a comma. Go. There we go. Okay, sweet. No errors, no warnings. We are absolutely within our rights to do everything here. Okay, sweet. Now we're back to normal. All right. Auto add component, where we're going to be taking an int component and we're going to return. I really need to change my settings not to do that. Void. Does this really look better than this? I think I like it always on the same line. Yeah, Saber, you got it. You knew what's up. Okay, so to add a component, what we need to do is grab the bit set, so M components. Then we're gonna call flip the value component. Now, the reason why this works, M component is undefined. Oh, components, sorry. The reason why this works is because this is a bit set, and all we're doing is flipping a value from 0 to 1, and that's it. Now, obviously, we need to check if that's what we actually want. We're gonna verify first, but that's the principle of it. Now, all this is gonna do is just set the value to 1. Now, there's a couple of ways we can actually go about doing this. We could set up maybe an event thing where it's like event, add component, or component needs to be added, right? Of some kind. Alternatively, we do it right now where it's like we add the component to some value here. We give this something. So something like, this is where I wanted the standard tuple to be, but the tuple, can I just go auto? Or maybe 5? The problem is with this tuple is that it needs to be known at compile time how long the length is gonna be. I guess I could have like the same thing where I give it like a set length, like potentially all of them, so 13. Invalid type for bit field. What do you want? Type name this rest. Wait, I'm dumb. What does a tuple want? Oh, also we need, hold on real quick. We need to count the number of bits set to true. Check if all, any, or none of the bits are set to true. Test. Accesses a specific bit. Operator. Okay, so what we're gonna need to do. What's the difference between, I want to check if something's already true before we actually flip it on, right? Or flip it. The idea is that maybe we look for the operator. We can either grab the operator value of that component because we know where it is, and then we do something with it, or we test it. Returns the value of the bit at the position POS counting from 0, where test position. Unlike operator, it performs a bounds check and throws out of range if the position does not correspond to a valid position on the bit set. Ah. The first version returns the value of the bit. The second version returns an object of type bit set reference that allows modification of the value. Ah. We should do this, right? So what we can do is flip the referenced bit. Destroys the reference. The bit class includes a reference as a publicly acceptable nested class. This class is used as a proxy object to allow the user to interact with individual bits of the bit set. Since standard C++ type, like references and pointers, are not built with enough precision to specify individual bits. Okay, this is what I want. So the operator, what is this? Reference operator, size T position. Gotcha. So we're gonna type is if reference, oh, I see, standard bit set reference. How do I actually call it? Or do I just go operator this? Because this just returns the value. This returns the information. Bitsert oh, I need to make it. Standard bit set 13 operator empty bracket. Invalid base class. Can I do M components dot operator bracket? Oh, there we go. Okay, that's what I wanted. Man, bit sets are complicated. So now we have our operator. And we want the reference operator though, don't we? Standard size position. So the position is component. There. If this is not true. Oops. Then flip it. Is that a good way to phrase that? Wow, that was so complicated. But this should allow you to be able to flip it via a reference, right? Although I guess these aren't references, it's just a bool. What's an example? Let's see, make a bit set. It's that information, binary literal for 42. For loop. Okay. C out, B1. Bracket. Oh. Oh, that's not it at all. Oh, no, that is it. Okay, M components, operator bracket. So this should just be bracket. Expected at expression. You're expecting... What are you expecting? B1 bracket 0. So it should be B1 component. Like that? Okay, there we go. So now this grabs that value. And then that can be set to true, modifies the first bit through reference. So this, we don't flip it. What we do is we go M components bracket component equals true. And that's how we set that. Okay. Okay. Now, can we flip in a reference? Yes, we can. So instead of equals true, we just go dot flip. Oh, never mind. Well, I guess we're already error checking anyway. So I think that's how we can do that cleanly, because we're doing it by referenced value, and pointers are not specific enough. Because I think what happens if you have a pointer pointing to a value in a bit set, it changes bit set values based on the size of the pointer. I think that's what happens. So if you flip a pointer value, like a pointer integer or something, at that space in the bit set, it'll flip everything after that up to like an integer. I think that's how that works. Or maybe it's more specific than that, but it's definitely not that small. But this is a referenced value to the original value. Now the question is this exclamation point this mean that turned false? I think that is what that means. Sets true. Modifies the first bit through bit set reference. 0, 0, 1, 0, 1, 0, 1, 0. Modifies 0 to true. Wait. After setting bit 0, B1 holds. Zero, zero, one. 1. Oh, because it's bit 0. Oh, wait, it's bit 0. Wait, I'm confused. Wait, is the bit set backwards? Why is this printing backwards? Hold on. Size t I equals 0. I is less than that. Plus plus I. Print B1I. Is, and then print that. So B1I 0 is equal to this value, which is 0. 1, 0, 1. Binary literal for 42. 1, 0, 0. So I guess I'm a little confused why the bit set is going backwards here. After setting bit 0 this, why would you do, what a weird example. Why would you do like this? I thought it would be 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. But that's not true. B1 holds that. Maybe I'm misunderstanding. The position of the bit to return, the value of the requested bit, an object of type reference. So what's the value here? So bit size reference 1110. Uh-huh. Okay, so you're making a reference ref equals BS2. Bit set for reference BS2. Okay. Auto info. Okay, so you're iterating it through, right? That's all this is. So info 1, reference equals false. Info 2, reference equals true. Info 3, flip. Info 4, which is just grabbing the information for that and C outing it. Reference equals VS1, info 5. 10101. What? Reference bit 0. Okay, that makes sense. So info, the first one, prints that reference value. So this is just a lambda expression, right? Where info just prints out whatever percent ID with it, where ID is just this. So it's an anonymous function, right? So info 1 means ID number 1. BS is just the bit set, this. So this bit set. And then the referenced value, the referenced bit is whatever it is, right? So 1. The reference bit is bit set bracket 2. So that would be this position, I think. So it should be 1110. That's why if you grab info, it returns false. Oh, because you're setting it to false. I see what's going on. So you're setting this value here to false. So it should print 1100. And it prints 1011. So I think what I'm learning is that bit sets work opposite the way I thought. In a bit set, the number 0, 1, 2, you're counting from the right. That's so weird. I guess it makes sense if you count in binary. So like, if you see the numbers like 101, you know that number is 1, hold on, 0, 1, 2, 3, 4, 5. It'd be the number 5, right? Because 101, you're counting from the very far right and then moving left. Okay, if you think about it like binary, it makes sense. Okay, I got you. I understand. I get it. Okay. 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 So that all being said, we are grabbing this component value. So if it was position, it would be referenced value 0. You're setting M components bracket 0 to true. M components bracket 0 is a bit set 13, where the bracket 0 is the first element, so it'd be on the very end of the bit set. Okay, Jesus. What is the resolution of my monitor? 2560 by 1080. It's a really weird resolution, but I wanted a super ultra wide screen that is just wide real estate. That's what I wanted. So this is what we did. It runs at 144 frames per second. I forget what the actual monitor refresh rate is, but it's not 120. It's higher than that, by like 144 or something. It's a weird one. But yeah, 2560 by 1080 is the resolution of my screen. Okay, so we have our bit set values. We have our operators. Beautiful. Now, what do we do from here? We have our stored bit set, all that good stuff, right? So what's next? Well, we need to actually get the component into the entity somehow. So how do we store our components? Well, there's a few ways, right? There's a few ways. If I'm trying to think in my head about how to do this. Okay. If we can't use a tuple. We need real-time storage of all of these pointers to structs. Those need to exist somewhere. Now, I thought we could just have a tuple, but that's not, we can't do that, right? Likewise, well, if we could have a tuple, there's no point in having the bit set. So I can just say, if it exists, then just use it. The problem is it doesn't fit our use case. If I knew how many components I was gonna have, I would give this entity every single component you could possibly have, but set its value to like uninitialized. I don't know if you can do that. And then you just initialize them as you kind of gain them. But I think because we have this whole bit set thing that we can turn on to check if it even has, this is what it's going to get iterated through every time a system needs to check if like anything has anything. Just iterate through all of these bit sets. The alternative would be, I don't know. What is like our alternative? It would need to be a system to store the information of components. You know what I could do is when we add the component, we could say, well, I don't know if I want like an event where it's like, oh, a bit set changed, check to see what changed and give the appropriate components. That sounds like a memory hog, or at least like a CPU bottleneck potentially. It's more of a problem of when I add the component, it needs to be more than a flipped bit set value. This just tells all the systems, hey, this has the component, but what do I actually do to add it? I guess what I could do is put all of these structs on a vector. No, that's not a good way to do it. I could give everything its own vector. And then we just add, when we add a component to the entity, we add it to the vector. Would the vectors contain? No, those vectors would just contain pointers, right? They would point to the referenced value, which is going to be contained in this entity probably. So are we gonna end up in the end with like a standard? Well, I mean, a complicated way to do it would be to just make a struct called component, and then we just make C position, C velocity, C bounding rect. Instead of structs, we could make them component objects. I don't know. Whew. I don't know. Also, these probably don't need to be exported anymore, huh? Because you probably don't want to easy access them. I don't know how to store components on a entity very well then. If we're like our use case anyway, where anything can have any component. Let's Google it. See what like Stack Overflow says and stuff. All right, so C++, how to store components in an entity. Okay, component simple base class from which move component derives. I store component inside of the world class, struct world vector components. That would work fine if it was only one type of component, like a component class for every example move component. Okay, so he has the same problem where a tuple seems perfect for this, but a tuple is fixed memory. You need to add to it. I guess we could make our own. This might be like the few times where we make our own container, right? We need a container that's variable length so it can assign its own memory when needed, like doubles its length every time or something. And we make our own container, variable length. It would behave like a tuple. And that's it. That's all I need it to do, right? It just needs to be a variable array, variable length array that's a tuple. Would that be hard to make? Yeah, 4 move components, so he wants to do anything, iterate through. Entity component systems store data in one of 3 ways: centrally allocated arrays accessible by all systems, contiguous arrays of subsets of components that each system is interested in, contiguous array of entities allocated in a centrally located memory buffer. Naughty Dog uses scenario 1. An entity in this context is just a collection of numbers. Struct, entity, static const, foo, bar, components, ID. The components of the above code are either -1, meaning no component of this type, or a positive number, 0 inclusive. This is an index to the centrally stored array of each set of components. Oh. So what this way of doing it is, if you say components, max components. So this is an array, right? And this is an index to a centrally stored array of each set of components. Component allocator, public, foo components, max foo count, max bar count. Then any system can use a singleton service locator pattern to get access to it and iterate over it. In scenario 2, your entity is the storage for each set of components, and each system stores a collection of proxies to that entity. So they contain a map that contains an index and a shared pointer I component, M components. Oh, we could store them in a map. Is a map not type enforcing for every element in the container? Can you make a parkour horror game like Finding Frankie? Buddy, I can make anything. Right now, we're making pseudo roguelike, pseudo not roguelike action game. It's fun. You'll like it. Our art's gonna be great. Dude, I love the art. Holy shit. What great art. No, not that. Oh, geez. Hold on. There we go. Oh, beautiful art. Hold on. Hold on. I got a good one. Boom. How's that for art? Oh, shit. Oh, yeah. We got art for this game. Can you make the horror game after then? I mean, I can make anything, but I'm in college right now for computer science. So, I don't know, man. Eddie, that boy is back. Thank you for following. I'm not a fan of horror games. I don't know if I could make a horror game very well. I like RPGs, roguelikes, that kind of stuff. Not turn-based RPGs. I just like RPG like aspects, you know? Our game is going to be a little shooty McShooter. I don't know. It's not a bullet hell because bullets aren't necessarily getting shot at you. It's its own unique thing. It's a little bit of innovation. So like first person shooter, not my game. Hell no. This is definitely top down. And it's not even a shooter. It's I don't know. Have you ever played would you call Binding of Isaac a shooter? I wouldn't. I would say it's a roguelike love letter to the Legend of Zelda series. That's also about abused children. Anyway, art for the game is beautiful. Okay, let's read up. Hold on, what does Stack Overflow say? Scenario 3 just allocates a byte array, which gets set with as many components as you need. This is also complex, but very good for embedded systems such as mobile devices and consoles. Oh, wait, that's what we're doing right now. What was scenario 3? A contiguous array of entities allocated in a centrally located memory buffer. Does a standard map have type enforcing? I guess that's my question. Because if I can store everything in just a map, that would solve a lot of our problems here. Because I need like a variable length tuple. It's such a weird use case, but I think that's justified. Class entity, public standard map, type index, shared pointer, M components. So what does a standard map need? Associative container that contains key value pairs with unique keys. Keys are sorted using the comparison function compare. Search, removal, insertion operations have logarithmic complexity. Maps are usually implemented as red-black trees. So here's the thing. This is what we want, because we're not searching through map. We're not iterating through a map. We're never doing anything like that. It's literally just have memory somewhere that I can access to give me some component information if I ever need it. We're iterating through bit sets as like a way to be like, hey systems, if you need to check if components need to exist in this entity, just iterate through this bit set. If we need to add a component, we'll flip on the value. All right, that's all you're checking. We just need a spot to actually store the components, you know? Let's see. BAP iterates in ascending order of keys, where ascending is defined by the comparison that was used for the construction. That is, given M as a map, it L and it R are dereferenceable iterators to M with it L and less than it R. M value comp it L it R pointers equals true, least to greatest if using the default comparison. Okay. Everywhere in the standard library uses compare requirements. Uniqueness is determined by using the equivalent relation. In imprecise terms, two objects A and B are considered equivalent, not unique, if neither compares less than the other. Oh. I get an example, thank you. So let's see, print map, yep, iterate, get it, key, perfect. Okay, all right, so map containing a string and an integer creates a map of 3 string int pairs. Ah, okay. Gotcha. So what we need to do is, oh yeah, Discord, sorry, link is directly below the stream. You'll see a link to Discord there. It's in the personal section or wherever it is. It should be down there in the links. So what we need to do we need to make a map that contains okay, hold on. Oh god. We need a vector that just contains every single component in the program. This vector will be then used in this map. No, maybe not. What does that guy on this say? What does he do? He does public standard map containing the type index and a shared pointer I component, M components. And that's how he's storing all of his components. Each system stores a proxy to the entity, but only has access to a subset of the components. The component is also the subject from the subject observer pattern, which allows any change in the component to propagate to any interested proxy. Well, this is a good way to do things. It carries a lot of boilerplate. Oh, God. Scenario 3, a contiguous array of entities allocated in a centrally located memory buffer. A contiguous array of entities allocated in a centrally located memory buffer. So like a vector that just contains all entities. So it just allocates a byte array, which is what we did, which gets set with as many components as you need, which is what we did. I'm assuming this is a byte array, this bit set. This is also complex, but very good for embedded systems like mobile devices and consoles. Interesting. You should have a channel that your Discord gives you game ideas and fan art if you do a game horror game. Oh, I already have one. Look. Fan art. Look at that Firefly Queen. Oh, hell yeah, we got fan art. Look at this. People making fun of my sub icon. More fun of my sub icon. A great sub icon. The glasses that we're using. Look at this Gary Dragon fan art. Holy shit, isn't that cool? I have the best community. People drawing me as a dragon. I don't even know why. I'm not a furry. I just made fun of Raptor, I guess. What else have we got in here? Hilarious. Classic. Oh, the goo wings. Oh, that's right. Space Cadet Aphrodite made me little goo wings. Cute. We were playing Path of Exile and we had a pair of wings on. There you go. I need to use that next time. Damn. Oh, this is the artist we used to commission for the game. She is a full-time concept artist, and I was like, damn, this is really good art. I'm gonna commission her, and we did. I did ended up being like a $3,000 commission. Aww, I have the best fan art, dude. Oh, Kasabian Eye. Oh, what great fan art. Oh my goodness, I could look at my fan art all day. Isn't this great? Dude, what a great, that looks like a title for like a game or something, or like the title card. What is this? Yeah, I kind of agree. Graphics do matter a little. Is voice acting graphics? What? Like, it's all immersion, so it must be. What? Oh. I remember this. Because I was like, what is graphics in video games? Graphics don't matter, but like, it's for like the user experience. I remember this. Good times. Oh, that's right. We were rating the rate the drip. Oh my goodness, that's right. Rate the fucking drip. Jesus. Oh, and then we did 3D art. This was my attempt at Blender. I did this in Blender. You can tell by the teal coloring. I tried to make a donut. It was complicated, man. Look at 3D rendering's hard. And this is my attempt at a flower, given the lessons that were learned. Is it a good flower? No, but it's my flower. Anyway, I thought that was interesting. All right, we're getting off topic, chat. Jeez. Data storage design. Let's see here. There's some problems with this data approach I want to point out. First of all, you assume you have a fixed number of components for each type. If not, you either waste memory if you have too few of one component type, or no memory for too many, and you can't easily expand it. Second is, you'll likely have all of the cache misses from your first idea, since the whole array won't fit into the L1 cache. Unless your data, or since your data is contiguous, it's less problematic, but depending on what component your system is working on, it might be a problem. First, you compare data from component type 1 with type 12, maybe already out of cache, and then read data from component 3 to write component 12 again. Third is just a speculation. Do you create every component from the beginning or when you need it? It seems like you want to do the first, in which case you have to check if a component is active or not. If you want to do it or even iterate over the hash map, you'll most likely generate cache misses again and again. When do we create components? Do we create components at the beginning or when we need it? It would be at the beginning, right? It would have to be at the beginning, because if I have an entity on screen that's like fireball and it has like a bounding rectangle, I'm going to be adding the, you know, explode or sound or lighting, whatever component we're going to add. I'm going to add that in as soon as the explosion happens. Oh no, it would be before, right? Now we just turn it on. I don't know. Did you read the whole text I just sent? In Discord? No. My approach is to have some sort of node that has an ID and a copy of some components with the same ID. The system are only working on those nodes, and only those nodes are all required because the same ID exists. A bit of redundancy, but that's intentional with networking in mind. Well, this game isn't going to have any networking. There is no perfect ECS. Each architectural approach to ECS has pros and cons. Let me evolve your idea a bit. You have groups. Then why not having group of entity types? That's it. For every different entity type, you make a group, so you know the entity ID, because when you are iterating, you just need to know the index. Pros: you already know the ID of the processed entity. You just need to store a short ID if you need to reference the ID of another entity in the same group. Best cache concurrency: extremely simple to use. You don't have to manage groups. Those are automatic. Cons: update order undefined. Not the best cache coherency for instructions. To refer to another entity, you need to identify both group and index inside group, but the good news is that you can probably just use 16 bits for group and 16 bits for the index. So how to implement: for each update. So this is like Java stuff, right? I can't see the Discord link. Okay, so in the Twitch stream, you'll see it below right here. Twitch stream, about me. Hi, I'm Gary. YouTube, Discord. We make YouTube videos on rare occasions, but that was more of a Path of Exile thing. I probably should make videos nowadays, huh? I just have to shave. I don't want to like publish a YouTube video where I'm like fuzzy, you know? I'm on a tablet. Oh, I don't know how you would get access to the Discord then, but don't worry. Just like hang around. I stream every single day, baby. No exceptions, even tomorrow. Oh, baby. But thanks for coming by. I appreciate your company. How would one look for entities with specific components in an entity component system? Off the top of my head, you would just have a vector of all of the entities, right? And then you would just iterate through and just do like a Boolean check. So like, or not even that. What you would do, ooh, actually, it's not even that. What you would do is you would have like, when you add a component, oops. When you add a component like this, what we're gonna do probably is add this entity as a pointer to a vector that contains information with that. So for instance, if I have this entity and it's like, if it has a position, right? If it has a position value, that bit turned on, we added that component. What we would do is we would have the entities with positions vector, and this add component, it would add this instance of this entity to that entities with position vector. Now it's important because when you have systems, rather than iterating through, I don't know, every single entity in the entire game, it would only iterate through things that have an active position component. And then, so let's say a system is like gravity or something, right? Well, the gravity would be concerned about, okay, where are you on the screen? Oh, you're in that vector? Okay, now I'm gonna check if you have, is moving. I should say is movable is what I should say there, but whatever. Is movable, right? Can be moving. Oh, okay, so now that you have that check, okay, now I'm going to apply gravity or something like that. Or is vulnerable to gravity, or is capable to be. Anyway, all that is to say, rather than iterating through every single entity in the game, we're gonna add these entities to certain. That's how you solve the problem. I don't need a map. Oh no, shit, I need to give it values though. I was about to say, do we need the entities to have a map that's indexing every single component, and then we give it values there? Or when we add a component, this entity gets moved to a certain vector, and that vector is what gets iterated over with systems. The problem is where do I actually store the information for that position point or something, or this Boolean value? Once we have that done, I think we're good. So for now, I guess I can export struct. Oh, you know what? No. Namespace data. What's the syntax for this? Namespace data. This namespace data will contain a standard vector export struct. You guys get what I'm getting at, right? I want to be like data blocks position or entities with position, position or something like that. And then it would be like we would iterate through that. I don't know. I'm undecided. Undecided how to do that. Have you tried making a Roblox game? Eddie, that boy is back. Thank you, Code Toil. Have I tried making a Roblox game? No, I never have. I think you have to know the language Lua for that. And I have C++ to learn. No offense to Lua. You guys are like our shoe polishers, okay? What is a Lua programmer but a shoe polisher for a C++ programmer? You know, you guys, I'm not saying you're less than us, but I am saying, come on, it's time. You should probably learn C++, right? Because I made one. Hey, that's great. I have only played Roblox once in my life, and it was with my friend Casavia, and I did it for her. She loves that game. We played it. It was a game. I remember things. All right, hold on. You know what we should do? Export struct. Entity. You know what? Actually, this needs to go below, huh? Ooh! Entity containers. And what we would do... Oh, shit. Wait, I'm in like a circular logic problem. What I'm thinking is we would do like standard vector type entity. And this would be entity. Oh, this works. Never mind. I don't know how that. Okay. I don't know how I can make a vector of entities when entity is defined immediately below it, but I dig it. Okay, so before we do anything, does this still run? Oh my God, it does. Based. And no warnings? Based. Okay. So, standard vector entity, we're gonna have E positions, E position. We're gonna just call it that. And this will just exist. And that's all I need. Basically, this vector just needs to exist. And we're gonna have one for every single thing. Is that wise? No, it's not wise. But that's what I'm getting at, is this would exist. So now, I don't even like this being a struct. Because that implies it's going to be like an object type. And I don't want this to be an object type. I just want this to be data. I kind of want this to be like namespace E containers or something like that. Is there, I forget the syntax for namespace stuff. Yeah, there we go. Identifier that and undefined. Okay, beautiful. So the idea is I just want to be like E containers blocks E positions. That kind of deal. Yo, is this object-oriented programming? Fuck no, it isn't, peas and carrots. This is ECS, baby. We don't do inheritance here. There ain't no this isn't your daddy's programming. This is modern C++, baby. We got modules and shit. Look at that. Look at this. Import standard library. Imagine chat having to type hashtag include permission to do math. Or like hashtag include permission to like do time or something like that. Why do that when you can just type import the standard library and just be fucking done with it? Holy shit, based. Okay, so now this is defined. What the fuck? Wait, this still runs, right? No, it does not. Vector entity is not a valid template type. Ah, because it's undefined. So I guess what I could do is now make it below this. Does that work? Yes, it does. Okay, sweet. When I come back, you should be almost done. Peas and carrots. Thank you for following. I appreciate it. Aw. Is this the way of the future? Yes, it is. Thank you for following. I'm glad. Look at this guy coming in here being like, hey man, follow, and just slams his dick on the table. I'm like, oh, Jesus Christ. You gotta be careful with that thing. Thank you. When I come back, you should be almost done. No, no, we're not even close. We're just doing, this is just to be clear, we haven't actually done any game design yet. This is just setting up our entity components before we do systems. Good news, once we have this done, life gets a lot easier and we can just blast off with designing. That's the fun part. And we're doing an engine from scratch, so we gotta do a lot of boring stuff like rendering. Okay, so we have our containers. The problem is I want to access this container in here and I can't. So what's the best way to do that? The idea, oh, I need an entity manager, don't I? That's what I'm learning. I need an entity manager. I'm rediscovering the wheel. The thing is that I need vectors containing the entity object type so I can have vectors to iterate through for our systems, right? That need to look through certain entities. The problem is I need to define what an entity is before I have this vector. Now, if I have an add component function and I want to add this entity to this vector when I do it, I need to know where that is, and I can't access this before. So what I'm learning is copy, delete, delete, delete. Then we're gonna have export class entity manager. Well, then I don't need this anymore because the entity manager will have that entity information in there. Hold on, that's wrong. That's right. Okay, beautiful. Okay, so M components is undefined because this is now undefined because now we need int component and entity comma, and now we need the entity.m components and the entity.m components. Why isn't this working? Is inaccessible. Oh God. Oh Jesus. How do we do this? I could make this public, but I really don't want to. I guess I can make this public first. That might help. Yeah, I don't have access to that bit set. You can always make an entity manager a friend of entity. Isn't that object-oriented programming though? We really want to do ECS here. I really don't want to do like... Wait, is that a pun? Is that like a joke? Did you just make fun of me? Chat? No, it's an actual thing. Coder of Paradise, you have rep here. All right, I'll believe you. We're not gonna do it. I'll roll with it. Chat, my hair looks stupid. I swear to God, I did not brush my hair with a rock today. It's super hot today and I'm all sweaty and it's just, ugh. My hair is so flat, it has no volume right now. Ugh. I have a bad hair day, chat. You can't make fun of me. Chat, does anyone else have a bad hair day sometimes? I have a terrible hair day today. Ugh. Better? It's better, right? Okay, we're not glitching out here. That's a little better. That's a little bit more tame. I can fly. So an entity, you would have a friend entity manager, but you would need to forward declare the entity manager first. Well, how about this? What if we keep this add component in the entity, but the entity manager will have I don't think we're gonna need to export this class. I think we can just keep it as a private thing. Well, same with these. I think we're gonna keep this as like a private thing in this module. It's almost like we're making a library. That's what it feels like. I want to keep it in this module, and then all we're gonna have as an export here, all we're gonna have as an export is this entity manager, and that'll handle everything. So we can call make entity, give it a name, give it a tag, give it an ID number. Well, no, it wouldn't even be that. And it would just take care of the rest. And if we wanted to add a component, it would be through the entity manager. And then it would add it to whatever entity we're talking about. Oh, but then I would need access to the individual entity, huh? Yeah, that does need to be exported then. I just want to be really careful to not give people access to this entity class, like this function. I really don't want to give people access to that. Quick example of a friend. We won't do it now, but I get what you're saying. Thank you though, I appreciate it. Thank you for the link. Is it long? Oh God. Oh no, it's really short. Okay, hold on, let's read this. I can't zoom in. Okay. Struct, entity manager, class, entity, private, friend, I'm assuming you're saying? Int variable, struct, entity manager, void run, entity e variable is equal to 5. Cannot be declared friend. Oh shit. Friend should be friend entity manager. Ah, dang, you were in a hurry typing this, huh? This should be. Unexpected struct. Did you forget a semicolon? Yep. Variable is not a member of. Something like that. There you go. That's what you wanted, huh? Okay. So friends can have access to private variables, huh? Okay. I don't hate that. So you're saying I'm assuming we have to export up there as well. So export this. And then we go public and we say friend. Invalid friend declaration. Updated. Thank you. Friend entity manager. Oh, I see what you're saying. So friend entity manager, semicolon. And just keep it like that. Something like that. Okay, I dig it. And then now we have access to these. So if I copy, paste, now we have access to it. Oh, that's so cool. Okay. Shit, you learn something every day, chat. I have never used this friend keyword ever in a class in C++. That's so weird. It just seems very unsafe, but I guess use case. Hey, anything's useful in C++ is simple. Chat, by the end of this project, I'm gonna type goddamn standard launder. I don't even think, do you guys even know what standard launder is? Also, why can't I do it? Hold on, where is it? What does it want? That's a thing. Hold on. Hold on, that's a thing. I'm not crazy. Where's my launder? I know you exist. There you are. Standard launder. I bet you guys even know that was a thing, huh? Provenance fence with respect to P returns a pointer to the same memory that P points to, but where the referent object is assumed to have a distinct lifetime and dynamic type. There's a lot of assumptions being made here, Chad. If this sounds like defining undefined behavior, that's exactly what it is. So this is kind of cool, right? So you have a struct, it's not cool, it's actually terrifying. You have a struct base containing a virtual integer, transmogrify, then you inherit from base a derived with int transmogrify override being new, this base return 2. Okay, makes sense. Then you have a base blocks transmogrify this, not this, the original virtual integer, new, this derived return 1. Okay, Then we static assert, yada yada, right? So it's assuming that it's all the same. All in all, class member accessed is undefined behavior. Reinterpret cast has value pointer to S and does not point to Y. So that's what the launder does. So int m standard launder base transmogrify, okay. But if you say int m equals base transmogrify, it's undefined behavior because of this whole override situation. Damn, you're a pro now? I am not a pro. Hello, I'm sorry for bothering you. I want to offer a promotion to finger me up the butthole. Oh, buddy, I'm so sorry. That language is not allowed here. I'm gonna have to ban you. I am so sorry. That is inappropriate. Hell yeah, undefined behavior. Did you guys see? Hold on. Oh shit. Did you guys see the did you guys see the proposal in C++? Well, no, it's coming in C++ 26. Look at this. Hold on. Where's my defining trivial loops? Where is it? There we go. Trivial infinite loops are not undefined behavior. Chat, do you want to know what behavior C++ is defining? Look at this. In Clang, you can do this. Include IOStream, int main, while true, semicolon. Then have a function completely not linked at all to main, void unreachable, hello world. Do you want to know what happens here? You print hello world. That's some undefined behavior if I've ever seen it. This is going to be defined as defined come C++ 26. What is undefined behavior but behavior that is yet to be defined? Yeah, damn. That's C++ can do some scary things, and in Clang, this is like C-Lang only. You can't do this in MBSC or anything. Oh man, look at that nightmare. Why is this shit allowed? This should not be a thing, but there it is. Trivial infinite loops are now going to be defined. I don't know why, I don't know how, but by golly, they will be defined. What it does mean is you can do this in other compilers. That's basically what it's going to be meaning. I don't know why you would. Maybe it's for compatibility reasons. I guess other compilers can now do what was previously undefined trivial loops. Okay, sweet. I have no, I can't, there's maybe some computer science reason why hello world prints here. I could not tell you. This is fucking terrifying. This is C++ at its like worst. I have no idea why this prints hello world. While true is optimized out. Okay, but then how does unreachable get called? I don't know. Maybe it's because main doesn't actually call a return statement, maybe? I don't know. Anyway, I have to end today pretty early. I know today was a super short stream, but I have essays to write for college for computer science, so I need to do that tonight. Oh, by the way, remember about standard array of standard unions? No. But in any case, we're not laundering anything. We're going to have friend entity manager. So tomorrow, what are we going to do? Actually, because we're going to have way more time tomorrow to stream. It's going to be like 3 times as long of a stream. What we're going to do is, besides just adding a component to this bit set, besides flipping a value in the bit set that we're going to check, we are going to be creating containers in this entity manager, just standard vector entity containers that, based on the component we add, will add to those containers. So systems know how to iterate through entities, and when it iterates through entities, it will then iterate through the bit set to see if it has the correct values flipped, and that's how we're going to keep track of components. Sweet. And we'll do that tomorrow and maybe get started on systems. I don't know. We're a long way away from the game loop. In fact, what's cool about this is that the game loop is like the last thing we do. It's like, we're like, everything about the game is designed, and then we just make the game, and that's where the game loop comes in. So that's kind of cool. That KS is not what it's used for. It's a gun. Wrong stream. Sorry. What? All right. Anyway, chat, come here. Come on. That's right. Stop looking at my IRL face. We're going to stream tomorrow. I'm a VTuber. Remember that. All right. Have a good night. Have a good evening. Give me kisses. Tasty. See you tomorrow. Bye. I don't want to write essays.